In this example, we're going to take a look at solving this equation. And you can see we have a couple of cube roots in here and a couple of expressions that are being raised to the power of 4. And we're going to add them together, and we're going to say that sum is 1. All right, so how could we do this? Well, we're going to start by making a substitution, and in fact we'll make a series of substitutions to take this equation down into something much smaller and more manageable, and then when we have something good to use, we'll build it back up, and then we'll deal with this larger structure. Okay, so we're going to start, and I'm going to say t is going to equal the cubed root of x minus, and then I need a term here. Well, the cubed root of x minus 5 halves and the cubed root of x minus 7 halves, these are almost the same, except, one is 5 halves and one is 7 halves. Well, 5 halves is 2.5 and 7 halves is 3.5. So how about we, split the difference and we use 3 because that's right in the middle of 2.5 and 3.5. So t equals this cubed root of x minus 3. Which means now I can go ahead and rewrite each of these expressions. And they'll become, let's see, t plus 1/2 to the power of 4 plus t minus 1/2 to the power of 4, and that'll equal 1. Okay, well, what should we do here? Because it doesn't seem like we did a lot. We made some headway. We got rid of that cubed root anyway. But now we have t plus 1/2 and t minus 1/2. So still they look a lot alike. So let's make this into a u, and let's make this guy into a negative v. Okay, and this will come back here in a bit why we're going to make this negative. So let's start here. I'll say u equals t plus 1/2, and v will equal, well, since this is negative v, we're going to change these signs. So this will be 1/2 minus t. So we have this nice system here. Well, rewriting this in terms of u and v, it's going to be u to the 4th plus negative v to the 4th equals 1. Well, the whole negative here being raised to an even exponent is nice, because really I can just say u to the 4th plus v to the 4th equals 1. And so one more thing we can do, let's add these two equations. So u plus v equals, and the t minus t, all those t's cancel. That's nice. And then 1/2 plus 1/2 is 1. So it looks like we have broken this problem down into this little system. U to the 4th plus v to the 4th equals 1, and u plus v equals 1 as well. Okay, well, how can we solve this? Well, u to the 4th plus v to the 4th, it kind of looks like the sum of two perfect squares. We could say u squared squared and v squared squared are being added. But there's no great factorization for that. So let's instead consider a property of quadratics here. So when we have this quantity x plus y squared, this equals, when I multiply it out, x squared plus y squared, but we also have this other guy, this 2xy as well. And so this is going to be an important property that we use in moving forward, because we're going to rewrite this equation in a manner using this property. So what's that going to look like? Well, I can say u squared plus v squared squared, which again is going to use this right here. But of course this isn't a perfect equality here because we had this extra 2xy, so let's just go ahead and minus that out. So we'll minus out 2u squared v squared, and that equals 1. Alright, so in our case here you probably caught it that the x was u squared and the y was v squared, hence why this was u squared v squared. Okay, well, I notice I have this same thing again, so let's do this one more time. So we'll call this u plus v squared minus 2uv, okay, and that's this, and that whole quantity is squared, minus 2u squared v squared equals 1. Well, that seems like quite a mess. Why would we go to all that trouble? Well, we see right here that u plus v equals 1, and I have a u plus v right here. So let's go ahead and change this to a 1. So 1 squared is 1. So I have 1 minus 2uv quantity squared minus 2, and I'm going to rewrite this as uv squared, just like that, equals 1. Well, okay. Let's make one more substitution. And we're going to say W equals U times V, because we have a UV here and a UV here. And instead of having two variables, let's just have one. So 1 minus 2W squared minus 2W squared equals 1. And so now we've whittled all this down to quite a nice little equation. So let's go ahead and solve this equation. I'm going to do so by first squaring this binomial. So 1 minus 4W plus 4W squared minus 2W squared equals 1. And right away these 1's will cancel, and we can combine some like terms. This is going to come out really nicely. So 2W squared minus 4W equals 0. And we can solve this by first taking out a greatest common factor. So 2W times W minus 2 equals 0. So we have this factor, and of course we're multiplying them and we're saying that equals 0. So we can use the 0 property of multiplication and say that, well, 2W equals 0 and W minus 2 equals 0, just accounting for both of those situations. This is nice because W equals 0 or W equals 2. Okay, but what was W? Well, it was U times V. So UV equals 0 or UV equals 2. And so we have these two statements right here, these two equations. Let's go ahead and also take into consideration this U plus V equals 1 once again. So U plus V equals 1. All right, so let's consider this first one first. If U times V equals 0, well, you know, it's because either U equals 0 or V equals 0. So we'll use that here in a second. Let's step over here. So UV equals 2 and U plus V equals 1. This system right here that we've created actually has no real solution, nothing that we can use. And if you'd like, you can go ahead and work that out on your own, but you'll see there's no usable solution here. So we're going to take this U equals 0 and V equals 0, and we're going to focus on that for a second. Okay, so I'm going to make a little room here, and we're going to rewrite this up here. So U plus V equals 1. And let's consider both of these solutions. U equals 0 and V equals 0. And so we'll just work these two one at a time. So if U equals 0, 0 plus V is 1, well, of course, that means V has to be 1. Well, what if V is 0? Well, that means U has to be 1. Okay, and then let's jump back up here and consider this system right here that we had. We had values for U and V, little expressions in terms of T. So we had U equals T plus a half and V equals a half minus T. Okay, so in this case, we see that U equals 0 and V equals 1. And in this case, we see that U equals 1 and V equals 0. So once again, let's talk about both of them. So here's the first one. If U is 0, let's plug 0 right here. 0 equals T plus a half. So that means T is negative 1/2. Well, I wonder if it holds for this other guy. So if T is negative 1/2, then V will be 1/2 minus a negative 1/2. So V is 1. Okay, and that's what we set up here. So this checks out. So we have one value for T. It's negative 1/2. Okay, how about this second situation then? So if U is 1, let's plug a 1 right here. So 1 equals T plus a half. When I subtract a half from both sides, I have T equals positive 1/2 this time. And again, let's plug it in here, see if it holds. V equals 1/2 minus 1/2. So V equals 0, and yes, indeed, V does equal 0. So this checks out as well. Okay, so two values for T. And we're going to come right back up here and look at our T expression that we had. We said T equals the cubed root of x minus 3. So let's go ahead and bring that down here. So we said T is the cubed root of x minus 3. And we're also saying that T is plus or minus a half. Okay, so let's kind of break this up and see what we have. So positive 1/2 equals the cubed root of x minus 3, and negative 1/2 also equals that cubed root of x minus 3. So in both cases, we're just going to add 3, and then it looks like we'll cube it. Okay, so one at a time. So 7/2 equals that cubed root of x. So when we cube both sides, it looks like x is going to be 343 over 8. Okay, similarly, when we add 3, we'll have 5/2 equals that cubed root of x. Okay, cube both sides, we have 125 over 8 equals x in this case. So it seems like we have two values of x that are going to work, and I would encourage you as well, just go ahead and plug them in, make sure that they work. So I'm going to say here, x equals 125 over 8 and 343 over 8 are going to be the two solutions for this original radical equation. It contained a couple of cube roots and a couple of expressions that we were raising to the power of 4. We added them up and we said it equaled 1. So those two solutions again were 125 over 8 and 343 over 8.